11th. We find sets all around us, like a dining set, a tea set, a set of rainbow colors, a set of color pencils, or a set of geometrical instruments. So what is the common feature in all the above? They all are collections of objects. In mathematics also we find collections or sets. So today we are going to learn more about the mathematical term sets. The set theory is a fundamental part of modern mathematics which is used in almost every branch of mathematics, including geometry, sequences, trigonometry, probability, etc. This concept was developed by a German mathematician Georg Cantor while he was working on trigonometric series. In this video, we will discuss the meaning of set, symbols associated with the set theory, and various ways of representing identification and listing of the members of a particular set. So let's start. Mathematically speaking, a set is a collection of well-defined objects. Now what does well-defined mean? It means that if we consider any collection of objects, then we should be able to clearly tell which object belongs to the collection and which does not. Let us understand this with the help of some simple collections. The first one contains the vowels of the English alphabet. So can you clearly tell whether the letter P belongs to this collection? Right, P is not a member of this collection. Without any doubt, we can say that only A, E, I, O and U belong to this collection. So this is a well-defined collection and hence it is a set. Let's check this one. 1, 3, 7 and 21 are the factors of 21. Is there any other factor which I have missed out? No. And if a number is given to you, can you decide whether it belongs to this collection or not? Yes, of course. This means it is a set. So what is your opinion about the collection of natural numbers? Just think of any number you know. Can you easily tell whether it belongs to this collection or not? Yes. So this collection is also a set. Now if I take a collection of 5 best Bollywood movies, is it well defined? No, because the answer will vary from person to person. My list of movies may be totally different from yours. This means it is not a well-defined collection and hence it is not a set. What can you say about the next collection? I have written 3, 6, 9, 12, 15. You may have written this and your friend may have written this. What can we conclude? So you see, we cannot define whether a particular multiple of 3 will belong to this collection or not. So it is not a well-defined collection and hence not a set. So children, I hope I was able to give you a clear picture of a set. So we can say that every set is a collection, but every collection may not be a set. Before we move further, let us discuss about some standard sets used in mathematics. These have been given special name for anyone to recognize them easily. Like N is the set of all natural numbers, W is the set of all whole numbers. If I just add 0 to N, I'll get W. The set of all integers is denoted by Z or I. Similarly, the set of rational numbers by Q and the set of real numbers by R. Few other sets which you will come across in class 11th are Z plus, Q plus, R plus and C. All these are well-defined collections. If I take a number, say 0.5, I can definitely decide that it belongs to Q, R and Q plus, but not to any of the remaining sets. Children, mathematics is sometimes called a language of signs and symbols. From constants, variables to various operations, symbols are widely used. So in this topic also, you will learn various symbols. First, let us discuss some key points which you need to know here. Sets are usually denoted by capital letters, which you may have noticed in the standard sets also. The objects which belong to a set are called elements or members of the set, and they are usually denoted by small letters like A, B, C, X, Y, Z, etc. This symbol is epsilon. It is a Greek letter which means belongs to. So if A is an element of a set A, we write A epsilon capital A. and read it as A belongs to A, or A is an element of A. Similarly, if A is not a member of the set B, we say A does not belong to B. For example, if we take a set of all the factors of 21, then 7 belongs to A but 5 does not belong to A. Is it clear? Next comes how to represent a set. There are three main ways of representing a set. One of them is a simple statement like the ones we have used till now. For example, set of all natural numbers, set of all factors of 21. We will stress more on the other two forms. The first one is called roster form or tabular form. Here the elements of the set are listed within curly brackets separated by commas. You can list them in any order and no element is to be repeated. For example, if A is a set of all the letters of the word mathematics, then we will write the letters M, A, T, H, E, I, C, S in curly brackets. So basically you have to write all the distinct elements present in the collection. The second method is called set builder form or rule form. Here we have to identify a single common property of all the members of the set. Then we represent the set by writing within curly brackets, denoting the element by a symbol X or Y or Z. This is followed by a colon or a vertical bar, which is read as such that after this we write the property which is possessed by all the elements. For example, this set A can be written in the set builder form as follows. We read it as A is a set of all X such that X is a letter in the word mathematics. To make it more clear, let us consider some more examples. If we take a set of even positive integers less than 7, then in roster form we will simply list all the even integers. In set builder form, we consider the property that the number is a multiple of 2, so we can write it in the form 2n, where n is a natural number. Children, you may have some other form in your mind, and that may also be correct. So we can write the set builder form in various different ways. You just have to be sure that your set is well defined. Like we can also write A as set of all x such that x belongs to z plus x is divisible by 2 and 0 less than x less than 7. Now B is a set of all natural numbers which divide 42. Can you list all the elements? The elements of this set are 1, 2, 3, 6, 7, 14, 21 and 42. So the common property of these elements is that they divide 42. In set builder form, we may write it as set of all x such that x belongs to n and x divides 42. In the third example, M is a set of natural numbers between 3 and 10. So they are 4, 5, 6, 7, 8, 9. Or x such that x belongs to n and 3 less than x less than 10. Can you try the next one? This is a quadratic equation and we have to find all the solutions of this equation. As you all know, we can solve it by splitting the middle term and we get two factors x minus 1 and x minus 2. This means in roster form s is equal to 1 comma minus 2. In set builder form, we can write it as set of all x such that x is a solution of x square plus x minus 2 equal to 0. In all these examples, we were given a descriptive form of the set and we converted it into roster and set builder form. Now let us consider this example where already the roster form is given and we have to convert it into set builder form. If you observe the members of this set carefully and try to find the pattern, you will see that each denominator is 1 more than the numerator and the numerator ranges from 1 to 6. So we can write A as set of all x such that x is equal to n upon n plus 1 where n is a natural number and 1 is less than equal to n less than equal to 6. So children, this was all for today. I hope you have understood all the basic concepts related to sets and how to represent the set in different forms. Leave a comment in the comment box if you have any question. And don't forget to like, subscribe and share. We will meet again in another session soon. Till then, take good care of yourself. Goodbye for now.